This is the spreadsheet you're going to be getting. These are some fake data or just some example data that you can use to check and make sure you've got everything working in your spreadsheet. So when it comes time for you to collect data, you can just pop it into these yellow cells. You can also extend this farther down if you want to. You can go further if you want more data points. There's nothing magical about having however many this is. So this is what all the right answers look like. And this is the graph that is produced that is useful in the end for figuring out where the egg is going to stop. And the answer is right here. 0.6 meters from the floor is where the egg is going to bottom out. Now, there's this column D in here. This is a relic. I could get rid of it, but then I would have to mess around and fix this graph. I've noticed that deleting that column just messes up my graph, so that's why it's there. So I'm going to walk you through how to set up the formulas in all these cells. I'm not going to give you the formulas. I'm just going to talk about what to do. So first, let me explain what these things mean. Total mass of stuff falling, height of egg bottom at release, height of egg bottom at stretch beginning. So here's the ceiling, and we're going to have some kind of a little hook, and you're going to have a bungee hanging from that with a loop on it. So that's how just the bungee looks. The egg, let me draw the bungee with the egg getting ready to go. So here's the hook. Here's the bungee looped over, and attached to this thing, there's going to be kind of a harness with the tip of the egg sticking out. That's the tip of the egg right there at the bottom. So this, let me change colors. This height right here, from there to there, that is the height of the egg bottom, height of the egg bottom at release. So on my numbers here, my example numbers, it's 2.6. And then height of egg bottom at stretch beginning, that's 2.3. Boy, this is a short bungee. I feel like I need to draw this or redraw this. So what that would look like is, or maybe even change the numbers. Here's the hook again. Here's the bungee. Here's the egg thing that's in. There's the egg. This next height, this is where the bungee starts to stretch. So there's the bungee at baseline. Here's the bungee sort of coiled up on itself as you raise the egg as high as you can to the ceiling. And then the egg falls and falls and falls. And when it gets to right here, this bungee starts to stretch again. So in my data here, it says 2.6 meters and 2.3 meters. So clearly what I've drawn here is not to scale. It doesn't really match the picture. And this distance that's falling right here, according to the fake data I've given you, that's 0.3 meters. Not very far. That's only about a foot. I made it look like farther than that. So this 0.2, that's the mass of all the stuff up there, the egg, and everything I'm circling right now. We know its mass. So this is an exercise in conservation of energy, and we're going to assume, well, let me do the last part. We're going to assume that between here, when the egg is lifted up to its highest point, and here, which is the point where the egg stops falling, from here to here, the total amount of energy, the total mechanical energy, remains constant. It's not really true. It's probably losing a little bit. There's some internal friction. If you let this thing bounce, it would kind of go up and down and up and down and up and down for a long time. But on that first fall, it's not going to lose too much energy. So I think it's a safe assumption. However, you can modify your spreadsheet to take into account reality. So if you look at my column J over here, I have 5.096 all the way down for total energy. If you want to start manipulating that so that decreases a little bit, if you think that would give you a more accurate answer, go ahead and do that. You're probably right, but the question is, How much does it lose? Well, there's no way to really tell that. It's not going to lose much, I can tell you from experience. So you're given this, and you have to populate it with formulas that make it look like that. Leave these numbers in, and then put your formulas in and check them with my numbers. So I'm going to start, I guess, from the left and explain what's going on here. This top row, the 2.6 meters, I'll show you the formula there. It just says equals B2. There's B2. So 2.6 meters is how high it is when you lift it all the way to the ceiling. And then next, 2.3, that's just equal to this. And then these following numbers depend on the stretch. So what you're going to be doing is hooking a force meter on to this thing. And here's the force meter, and here it is connected to your laptop. And you're going to pull the force meter down, 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 down. And as you do that, you're going to get forces that, like, if this is a force versus distance graph, your force is going to go up. So the data that I gave you, they represent the distance, total distance stretched, and the force on the force meter or force sensor. So no stretch, no force. 0.4 meters, 0.98 newtons. 0.8 meters, 1.96 newtons. 1.1, 2.94. I've got a little graph down here so you can see how what's happening. That's showing force and distance, just for fun. You don't really need that graph for anything. So if this is what you're measuring, you have to figure out the new heights of the egg bottom from that. So if the bottom of the egg is 2.3 meters, when it's just like about to begin stretching, then after stretching 0.4 meters, the egg's going to be 0.4 meters lower than that. And then after stretching to 0.8, it's going to be 0.8 meters lower than this. So there are a couple ways to do formulas here that are time saving. You could just put a little formula here that takes the number above and subtracts this difference. So for example, equals 2.3 minus 0.4 minus 0. And then when you copy that down, you're going to, down here it's going to be this one equals 0.9 minus the difference between these two. That's how you take care of those. The next thing I would do, gravitational energy, it should be easy because you can use let's just use the height of the egg bottom as h for mgh, which is how you get gravitational energy. And the mass is this. So it's the mass of the thing that's falling. And then h, well, you know g. So these are all just mgh. When you get to zero height, you get to zero gravitational energy. Now you can assume in the beginning, the egg, let me go back to this picture, when it's right up here at the top, it has no kinetic energy, has a lot of potential energy, it has no spring energy. So those are the three types of mechanical energy. You can get the total energy. So you can see here I have gravitational plus spring, which I don't even want you to bother with. I don't know. I could make that. That doesn't need to be blacked out. But anyway, we could put 0 in there. Kinetic energy is 0. I kind of wish that were not black. So I'm going to make that 0 here. And I think on yours, the other class has already got this. So there. I like it better this way. Okay, so here are the three types of energy. You add them up to get that. That total presumably remains the same. So as the gravitational energy decreases, these other energies increase. One very important note is that as you do work stretching this, so when you hook on this force sensor right in this picture right here, and you hook it on there and you pull, you're doing work, which is force times distance, and that work is stretching the spring, so it's going into spring energy. You're putting energy into the spring. There's no weight on it at this point. All you're doing is adding energy to the spring. So this column right here work done stretching the spring should equal the spring energy. So those are easy ones to do. Those just equal that. And if the total remains the same, and we know the gravitational, and we know the spring, then we can calculate the kinetic. It's just going to be the total minus those two. So you get the kinetic energy. Kinetic energy is really where it's at, because what we want to know is when is the egg going to stop, and that's the point where it has zero kinetic energy. So you can see the kinetic energy goes up from zero, then it goes down, 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 goes negative here. So somewhere between there and there is where the bungee is going to stop, and this graph makes that easier to see. It's right there, 0.6 meters. I can't think of anything